Hello. So this will be the last video for this chapter, and I would like to give you another exercise uh, for the binomial distribution. So in this example, we are considering inspection, quality control of a manufacturing firm. So suppose that a firm manufactures batteries, whatever, like batteries for electric vehicle. And the probability of a battery being defective is 5%. So 5%. So I've never seen a battery, how battery is manufactured. But suppose that, or simply think about the battery you use, AA battery. So a single battery can be defective with 5%. And you ship your batteries to a client, and the client screens the quality of the batteries. So your client inspects this way. First, randomly choose 10 batteries out of your shipment and check if they are defect or not. So 10 batteries are checked and accept only if 2 or fewer batteries are defective. Right? So in this case, I'm going to define Y as the number of non-defective batteries from the inspection. Right? Do you get it? And then in this case, what is the probability that the battery shipment is rejected? Think about this. So I believe you understand the scenario. It's like you are randomly choosing 10 and see if, so you will ask for a refund or exchange if there are 3 or more batteries. I mean 3 or more batteries are defective. So accepted only when 2 or fewer batteries are defective. Then what is probability that of rejection? So let's do it carefully. Y is the number of non-defective batteries, and your shipment is accepted if 2 or fewer batteries are defective. Then, but we are interested in rejection. So so you have to switch many buttons. So rejection now, let's think about this as rejection. So your client will reject your shipment if there are 3 or more defective batteries. Excuse me. If there are 3 or more defective batteries, you will be rejected. But now you are counting non-defective batteries. So when I say 3 or more are defective, that means there are 7 or fewer non-defective batteries, right? 3 defective batteries equals 7 non-defective batteries. So the answer is E. Do you get it? Right? So what makes you confused is, first, acceptance and rejection are the flip sides of coin. And here I'm talking about defective batteries, but we are counting non-defective batteries. So you have to change them, switch them, flip them. So you have to flip 2 dimensions, and then in the end you get E. It's like quiz game. And then so anyhow, the answer is probability smaller than or equal to 7. And this random variable y is another binomial distribution. Oh, I just heard a thunderstorm. I was surprised. So the parameters for y are 10 and 95%. First, n equals 10 because the maximum number of non-defective batteries is 10. Because you are inspecting 10, then at most there are 10 non-defective batteries when every battery is fine. and the probability of success. If you define Y this way, success is non-defective battery. So battery is defective with 5%, then battery is non-defective with 95%. So it is 95%. So you should be careful in the parameters. And then we would like to calculate this guy, but as I said, inequality cannot be directly calculated according to our formula. So you have to break it down to this. So smaller than or equal to 7 implies 7 or 6 or 5 or 4 or to 0. Right? There are 8 different cases included in this inequality, which is very cumbersome. So you may want to use the other side. The other side might be more useful because so it includes everything but 3 cases. So only count these 3 cases. That would be easier if you use the binomial probability formula. If you use the formula directly and calculate each single probability, then you have to do it this way. However, if you use Excel, then it's actually easier because I will show you formula binomial distribution. In our example, you are calculating cumulative distribution to 7. So the probability itself, the original probability itself, is a cumulative probability. Probability is smaller than or equal to a certain number. So it is a cumulative probability. So just put in as it is 7 out of 10 batteries, 7 or fewer non-defective batteries, and that probability is 95%. Probability is this. Change it to probability. It's 1.1504, which is what we get, right? Up to rounding errors. So this is another example where you can use the binomial distribution. So binomial distribution can be found in many places in your daily life, but calculating that the exact probability is not simple. There is no rule of thumb. So be careful when you need to calculate such a probability. Okay, this is the end of the chapter. I thought this lecture would be short, but actually not that short. Okay, and now in the next week, I am going to start chapter 6, right? Chapter 6, which is about the normal distribution. And from chapter 6 till the end of this semester, there is no everything is continuously related to each other. So all the chapters are interconnected very closely from the next one. So you should pay particularly more attention to the next chapter. Okay, have a good weekend. See you later.